So I'll just scroll down a little bit. The next calculation is for the first creep reduction. It's bracket, rafter spacing, plus bracket again, half the hip times 1.414, close bracket, minus half the rafter, which is the half the rafter thickness, close the bracket, and then you would multiply it by the tree length of common rafter per metre run. We haven't determined the half thickness of the hip yet, but as I said before, ridges and hips for this scenario were going to be 20 millimetres. So half the hip would be half of 20, so 20 divided by 2, which would give us a half thickness of hip of 10 millimetres. And we multiply that by 1.414 because the line that we're measuring along is at a 45-degree angle to the half hip thickness. So we need to find out what the length of that is by multiplying it by 1.414. That's why that's there. So inputting that into the calculator, we start with a bracket and the rafter spacing, which this scenario was 600 millimeters, so 0.600, plus, and then another bracket, half the hip, which we said was going to be 10 millimeters, so as meters that's 0.010, times 1.414 times 1.414, close that bracket, minus half the rafter thickness, which was 25 millimeters, so as meters that's 0.025, close the bracket, and then times by a tree length of common rafter per metre run, which was 1.155 equals. So our first creep reduction is 681 millimeters. The 4 will be rounded up by the 5, so that 0 becomes a 1. So the first creep reduction will be 681 millimeters, or 0.681. So we'll just put that there with a sticky note, 0.681. So that's the first creep reduction. I'll just clear that calculation.